Did you know your cake batter is a secret psychology lesson? When Piaget tested kids by reshaping clay, 90% failed his famous conservation test. But this chocolate cake, it'll make you understand the theory faster than any textbook. Let's fake and learn. What if the secret to understanding one of psychology's most fascinating theories has been hiding in your kitchen all along? Imagine this. A child watches as you pour milk from a short, wide glass into a tall, narrow one. "There's more now," they declare, certain the liquid multiplied simply because its shape changed. This isn't magic, it's Piaget's conservation. Theory in action, a cornerstone of how humans learn to grasp constancy in a world of transformations. But who needs a lecture when you could bake your way to enlightenment? Today, we're ditching the textbooks and grabbing a whisk. By the time we're done, you'll not only have a masterpiece of chocolate cake cooling on your counter, you'll see how melting chocolate, swirling batter, and even slicing the final product mirror the exact mental leaps Piaget observed in his groundbreaking experiments. Think about it. When a toddler insists a smashed cookie becomes more cookies, they're wrestling with the same principle that makes flour in a bowl seem like a different quantity than flour spread across a counter. Shape changes, but substance stays. This cake isn't just dessert. It's a time machine to the developing mind, ready to crack the code on cognitive development while mastering a recipe that'll make you the star of every dinner party. Let's get mixing. Welcome to Cognitive Kitchen, where dessert meets developmental psychology in the most delicious way possible. If you've ever wondered how a child learns that squishing a ball of dough doesn't actually change its mass, or why pouring milk into a taller glass suddenly makes it seem like there's more, you're about to get your answers. Today we're baking a chocolate cake that doesn't just satisfy your sweet tooth. It unlocks one of Jean Piaget's most groundbreaking discoveries about how our minds grow. Let's start with the basics. Piaget wasn't just some guy scribbling theories in a dusty lab. He was the architect of modern child development research, the one who realized that kids don't think like tiny adults. Their brains aren't broken. They're just wired differently, building understanding through stages. One of his most iconic insights? Conservation. The idea that quantity stays the same even when shape changes. Simple, right? Not so fast. Try convincing a 4-year-old that smashing a cookie into 3 pieces doesn't mean they've magically created more cookies. So how does this tie into cake? Because baking is all about transformation. Flour shifts from a pile to a batter to a fluffy dessert. Chocolate melts, reshapes, but never disappears. Every step mirrors the mental leaps Piaget observed in his experiments. By the time we're done, you'll see that cake isn't just a treat. It's a timeline of cognitive development on a plate. This is cognitive cooking, where mixing bowls become classrooms and frosting doubles as a lesson in constancy. Ready to prove that learning can be as satisfying as dessert? Let's dive in. Let's rewind to a moment you've probably witnessed, maybe even lived through. A child watches as you pour their milk from a short, wide glass into a taller, narrower one. Their eyes widen and they protest. There's more now. To them, the liquid has multiplied, magically increasing in volume simply because its shape changed. This isn't just innocent confusion. It's a window into one of the most fascinating milestones of human cognition. Welcome to the world of conservation, a concept so foundational to how we understand reality that Jean Piaget built a cornerstone of his cognitive development theory around it. Conservation, in Piagetian terms, is the realization that certain properties, like quantity, mass, or volume, remain constant even when their outward appearance changes. It sounds simple, but this understanding doesn't arrive fully formed in our minds. Instead, it develops gradually, like learning to walk or talk. For most children between the ages of 4 and 7, the idea that shape doesn't equal substance is still out of reach. They're stuck in what Piaget called the pre-operational stage, where thinking is rigid, literal, and dominated by what the eyes see. To them, a flattened ball of clay has less because it's wider, or a cookie shattered into 3 pieces has more because there are multiple fragments. Their logic isn't flawed, it's just incomplete, anchored in appearances, rather than abstract principles. This isn't a failure of intelligence. It's a symptom of cognitive scaffolding still under construction. Piaget's experiments revealed that children at this stage lack two critical mental tools: reversibility, the ability to mentally undo an action, and decentration, the capacity to focus on multiple aspects of a situation at once. If you stretch a piece of dough into a snake shape, a 5-year-old might insist it's longer now, unable to grasp that stretching hasn't added or removed any material. They fixate on the new length, while ignoring the unchanged thickness. Only as they mature into the concrete operational stage, roughly ages 7-11, do these mental gears click into place, allowing them to reason that some things stay the same, even when others change. But why does this matter beyond childhood? Conservation isn't just about milk glasses or cookies. It's the bedrock of scientific thinking, mathematical reasoning, and even everyday problem solving. Imagine trying to measure ingredients without trusting that a cup of flour remains. A cup, whether it's heaped or leveled, or struggling to grasp that melting ice doesn't disappear. It just shifts form. These are the cognitive leaps Piaget documented, showing how we build a mental map of constancy in a world of constant transformation. And here's the twist. Adults often forget how hard-won this understanding was. We take it for granted, assuming it's obvious that a pancake batter's volume doesn't vanish when baked into a fluffy cake. But remember, what feels intuitive to us now was once a puzzle to our younger selves. This is why conservation isn't just a childhood quirk. It's a testament to how our minds grow layer by layer until abstraction becomes second nature. So how do we make this invisible process visible? By doing exactly what Piaget did, manipulating the physical world to reveal the rules beneath the chaos. And what better way to explore transformation than through the alchemy of baking, where flour becomes cake, chocolate melts into sauce, and shapes shift while quantities stay stubbornly the same. Let's get cooking. What makes this chocolate cake the perfect partner for Piaget's conservation theory? Because every step of the baking process is a hands-on lesson in how appearance doesn't equal reality. Think about it. When you measure out 200 grams of flour, does it matter if you scoop it loosely or pack it tightly? No, the weight stays the same, even if the volume looks different. That's conservation of mass in action. And when you melt chocolate, does it suddenly become less just because it's no longer solid? Of course not. Its form changes, but its essence remains. These aren't just cooking techniques. They're tangible demonstrations of a child's journey, from believing that shape equals quantity to understanding that some truths persist beneath the surface. Even the batter itself is a metaphor. Imagine pouring it into a round pan versus a square one. To a young child, the square pan might seem like it holds more, simply because the shape stretched the boundaries of what they expect. But you know better now. The amount of batter hasn't changed. It's just wearing a new outfit. This mirrors exactly what Piaget observed when kids watched liquid poured into differently shaped containers. By the time you slide that pan into the oven, you're not just baking a cake, you're baking cognitive development. And when you slice the finished product, thick or thin, each piece still adds up to the whole. Shape changes, quantity stays. That's the heartbeat of conservation. Ready to see this theory rise? Let's get mixing. Let's dive into the heart of this chocolate cake experiment, where every scoop, stir, and pour becomes a lesson in cognitive development. First, grab your measuring cup and a bag of flour. As you scoop out 200 grams, pause for a moment. Does the flour suddenly feel heavier if you pack it down? Lighter if you fluff it up? Of course not. Whether it's a loose, cloud-like mound or a compact block, the weight remains unchanged. This is conservation of mass in action. A child in Piaget's pre-operational stage might insist the packed flour has more because it looks denser, but you know better. The substance itself hasn't changed, only its appearance has. Now melt 150 grams of dark chocolate. Watch as it transforms from solid chunks to a glossy, flowing liquid. Here's the question. Did the chocolate lose any of its chocolateness just because it shifted form? Not a bit. Its essence, its flavor, its richness, its weight, stays the same. This mirrors Piaget's experiments where children watched clay reshape from a ball to a snake. Young minds often believe the longer form has more clay, failing to grasp that stretching doesn't add or subtract material. But you're witnessing the same principle here: transformation without loss. Next, mix the batter. Combine your flour, melted chocolate, eggs, sugar, and milk until smooth. As you pour the batter into a round cake pan, consider this: what if you poured half into a square pan instead? To a 5-year-old, the square pan might seem like it holds more simply because the edges stretch differently. But you know the truth: the total volume of batter hasn't changed, it's just wearing a new shape. This is conservation of volume, a milestone Piaget identified as critical to logical thinking. Children don't master this until around age 7, when their brains develop the ability to mentally reverse actions, like imagining the batter flowing back into the mixing bowl, and focus on multiple aspects at once: thickness and length of the container. Here's where things get even more interesting. Slide both pans into the oven. As the batter bakes, it expands, rises, and solidifies into cake. But has the quantity of ingredients actually increased? No. Heat merely redistributes the matter, creating air pockets that change the texture. Piaget would call this a non-conservation error if a child assumed the taller cake has more than the flatter one. Yet you're witnessing the opposite: the same ingredients transformed structurally but constant quantitatively. Finally, let the cake cool. Slice it thick or thin, layer it with frosting, or crumble it into a parfait. Each piece, no matter the size or shape, still adds up to the whole. This isn't magic, it's conservation of area and number. A child might think cutting a cookie into 3 pieces creates more cookies, but you're living proof that division doesn't equal multiplication. You've just baked a physical metaphor for cognitive growth, the realization that some truths endure even when appearances shift. By now your kitchen should smell like success, and your mind should be buzzing with the elegance of Piaget's insight. Cooking isn't just about following steps, it's about understanding how the world works through tangible, edible experiences. Ready for the final act? Let's see this theory rise to its sweetest conclusion. Here's where the real magic happens, not just in the oven, but in the mind. As the cake bakes, let's dissect this moment. Picture a child watching you pour milk from a short, wide cup into a taller, skinnier one. There's more now, they insist, their logic anchored to what their eyes see. Sound familiar? This is Piaget's conservation theory in its rawest form, a cognitive checkpoint every human passes through. And now, thanks to your mixing bowl, you're about to witness it unfold in real time. Let's rewind to the flour. When you measured out 200 grams, did you pack it tightly or let it fluff up? It didn't matter. The weight stayed the same. Yet if a 5-year-old watched you do this, they might argue the packed flour has more because it looks denser. This is the heart of pre-operational thinking, the belief that appearance equals reality. A child at this stage lacks 2 mental superpowers Piaget identified: reversibility, the ability to mentally undo an action, and decentration, the skill to focus on multiple aspects at once. They fixate on the flour's density, unable to grasp that pressing it down doesn't create new matter. But you know better. You've already mastered conservation of mass. The flour didn't multiply, it simply changed shape. Now think, back to the chocolate. Melting it transformed it from solid to liquid, but did the chocolate lose any of its essence? Of course not. Its flavor, its richness, its weight, none of it vanished. This mirrors Piaget's famous clay experiment. A child sees a ball of clay rolled into a snake and claims it's longer now, failing to realize stretching doesn't add or subtract material. The child's brain hasn't yet grasped that physical transformations don't erase or expand quantity. But you've already developed concrete operational thinking. You understand that melting, stretching, or squishing doesn't alter the fundamental amount. It's just a costume change, and then there's the batter. When you poured it into the round pan, it took one shape. But what if you'd split it between pans, a round one and a square one? The square pan might look bigger at first glance, but you know the truth. The volume of batter hasn't changed. This is conservation of volume, a milestone Piaget observed emerging around age 7. Younger children often fail this test, mesmerized by the new shape. They'll swear the taller container holds more, unable to mentally reverse the pouring action or consider thickness alongside height. But you've got that mental flexibility down. You can picture the batter flowing back into the mixing bowl, proving the quantity never shifted. Now imagine the cake cooling on your counter. Let's slice it thick or thin. Does cutting it into more pieces mean you've created more cake? A toddler might nod yes, echoing Piaget's cookie experiment, where shattered cookies became more cookies in their eyes. But you're operating on a higher plane. You've mastered conservation of number and area. Division doesn't equal multiplication. A cake cut into 8 slices isn't more than one cut into 4. It's just sliced differently. This is the cognitive leap Piaget documented, the moment a child realizes that redistribution doesn't mean creation. So what ties all these steps together? Transformation without loss. Every stage of this recipe mirrors the exact mental hurdles Piaget identified. Flour reshaped but unchanged in mass, chocolate melted but constant in volume, batter poured but unaltered in quantity, slices multiplied but whole in essence. This cake isn't just dessert. It's a timeline of cognitive development baked into edible form. And here's the kicker. Adults forget how hard-won this understanding was. We take conservation for granted, assuming it's obvious that a melted chocolate bar hasn't disappeared. But remember, this wasn't always true for you. There was a time when your brain was building those neural pathways, layer by layer, just like this cake layers in the pan. Piaget's work reminds us that cognition isn't static. It's a dynamic process of building, testing, and revising mental models. Your cake just made that process visible. So as the aroma of chocolate fills your kitchen, celebrate this dual triumph, a dessert that satisfies your sweet tooth and a lesson in how the human mind grows. You've just lived Piaget's theory. No textbooks, no lectures, just a whisk, a bowl, and the quiet magic of transformation. Ready to taste the fruits of your cognitive labor? Let's slice this cake and savor every bite. As the cake bakes, the kitchen fills with the rich aroma of chocolate, a scent that signals both culinary success and cognitive revelation. This isn't just dessert in the making. It's a living experiment in Piaget's conservation theory, where every rising crumb reinforces the idea that transformation doesn't erase constancy. Let's finish this dish and see how the layers of learning stack up. When you slide the pan into the oven, you're witnessing conservation in action. The batter expands as heat works its magic, puffing into a dome that might fool a child into thinking it's more than what you poured in. But you know better. The air bubbles trapped in the mixture are just redistributing the same ingredients, creating volume without adding mass. This mirrors Piaget's observations of children struggling to grasp that a flattened clay ball hasn't lost its substance. It's simply redistributed. The cake's rise is a lesson in perceptual trickery. Something can look bigger without being more. Now the final stretch. Once baked, let the cake cool completely. As you loosen the edges with a knife, notice how the shape remains intact. A solid block of chocolatey proof that the pan's dimensions didn't define the cake's true size. This is conservation of area. The surface might stretch to fill the corners, but the total quantity stays the same. A child might argue that a cookie split into 3 pieces has more than one left whole, but here's the kicker. Cutting doesn't create new matter. It just rearranges what was already. Their time to slice. Grab a serrated knife and cut a thick wedge. Now cut another wedge twice as thin. Does the thinner slice have less cake? No, it's just portioned differently. This is conservation of number and area colliding. Piaget's experiments showed that young minds often conflate size with quantity, believing that spreading out objects like coins on a table increases their count. But your cake slices defy that logic. One thick slab or 10 slivers, it's still the same whole. Now plate it. Add a dollop of whipped cream or a drizzle of ganache if you like. Here's where the theory becomes tangible. As you lift the first bite to your mouth, you're not just tasting chocolate and sugar. You're tasting cognition itself. The flour, eggs, and chocolate you measured hours ago have undergone a series of transformations, solid to liquid to solid again. But their essence remains unchanged. Just like the child who once believed a shattered cookie multiplied, you've moved beyond appearances to grasp the truth beneath. And here's the final, Twist: conservation isn't just for kids. Adults use it daily, whether measuring ingredients, dividing leftovers, or even interpreting maps. The ability to see past superficial changes, to know that shape substance, is a skill that shapes everything from math to science to common sense. Your cake didn't just teach you Piaget's theory, it reminded you how deeply these principles are baked into everyday life. So take a bite, savor the proof in your hands. You've just turned flour and eggs into a masterpiece of psychology, one that tastes as good as it teaches. Ready to try another concept? After this, who knows what else you'll master? Oven. Mitts on, mind open, and appetite for learning fully ignited. Here's the moment where everything comes full circle, where flour, chocolate, and curiosity transform into something far richer than dessert. As you look at that slice of cake in your hand, you're holding more than just a treat. You're holding a timeline of cognitive development, a physical proof of how our minds learn to see beyond appearances. Every step of this recipe, from measuring flour that stayed 200 grams whether packed or fluffed, to melting chocolate that never lost its essence, to slicing the final cake without changing its total volume, mirrored the exact mental leaps Piaget documented in children. This isn't just baking, it's an edible psychology lab. Think about it. When you poured batter into differently shaped pans, did the quantity change? No. When you cut the cake into thinner slices, did you create more cake? Absolutely not. Yet these are the very illusions that stump young minds still building their understanding of conservation. Piaget showed us that grasping constancy under transformation isn't innate, it's learned. And today you lived that lesson. The flour didn't vanish when mixed, the chocolate didn't disappear when melted, and the cake didn't multiply when sliced. These truths feel obvious now, but they weren't always. There was a time long ago when your younger self would have struggled with the same questions a 5-year-old stumbles over. That's the beauty of Piaget's work. It reminds us that knowledge isn't static. It grows, layer by layer, just like this cake. So what does this mean beyond the kitchen? Conservation isn't just about milk glasses or cookies. It's the foundation of logical thinking. It's how we measure ingredients without second-guessing, how we trust that melting ice becomes water without losing mass, how we navigate a world of constant change without losing our grip on reality. Today, you didn't just bake a cake. You traced the path from rigid perception to abstract reasoning, from believing that shape equals quantity to understanding that some truths endure beneath the surface. Now, take another bite, savor it, and ask yourself, what other concepts are hiding in plain sight, waiting to be uncovered through your hands, your senses, and your curiosity? Share your thoughts below. Did this cake make Piaget's theory click? What other ideas should we bake next? Let's keep cooking and learning together. Here's where we tie it all together, where flour, chocolate, and curiosity become more than just a cake. You've just witnessed how a simple recipe can unlock one of Jean Piaget's most profound insights, that our minds evolve to see past appearances and grasp the constancy beneath change. This isn't just about baking, it's about understanding how we learn, grow, and make sense of a world that's constantly shifting. By now, you've measured conservation of mass in grams of flour, melted chocolate to prove volume stays steady, despite form, and sliced a cake to demonstrate that division doesn't mean multiplication. These aren't just cooking tricks, they're cognitive milestones. Piaget showed us that knowledge isn't static, it's built step by step, much like the layers of this dessert. And today, you've lived that process. But this is only the beginning. Think about the broader implications. How conservation underpins everything from math to science to everyday problem solving. How trusting that a melted ice cube hasn't vanished, or that a flattened ball of dough still holds its original mass, shapes our ability to navigate reality. These principles aren't just for children, they're the bedrock of critical thinking, hiding in plain sight in our kitchens, classrooms, and lives. Now take a moment to reflect. Did seeing Piaget's theory in action change how you think about learning? Could other abstract ideas, like gravity, entropy, or even empathy, be taught through something as simple as a recipe? Share your thoughts below. What concepts should we bake next? Maybe object permanence with hidden ingredients. Egocentrism with a shared dish. The possibilities are endless, and your curiosity is the recipe for what comes next. If this video made you see psychology and dessert in a new light, hit that like button. Subscribe to Cognitive Kitchen so you never miss another lesson in edible psychology. And don't forget to leave a comment whether you're asking questions, sharing your own aha moments, or suggesting the next concept we tackle. After all, this channel isn't just about recipes, it's about proving that learning is most powerful when it's hands-on, relatable, and, yes, delicious. So until next time, keep stirring, keep slicing, and keep wondering. Because in every bite of cake there's a piece of human understanding waiting to be savored. Cognitive Kitchen, where psychology meets the kitchen.